Now we have to know that there's a 2's complement system, and the 2's complement system uses 2's complement numbers in it. We wish there were a name for the 2's complement system that is different than 2's complement, because 2's complement is a type of number. But at any rate, the 2's complement system is a way of representing signed numbers. We can't, a computer doesn't just put a plus or a minus like we do when we're writing math on a piece of paper. It has to represent the sign as an extra bit, and it uses that extra bit in a very specific manner. So the 2's complement system is going to use these 2's complement numbers that will put a sign bit. But first, we have to know what a 2's complement number is. So here's what a 2's complement number is. It's pretty simple. It's what we have to do to take a 2's complement number is we first take the 1's complement. Then we add a 1 to the least significant position. And right now we're kind of rolling our eyes, probably thinking, do I want to listen to this person? Does this really make sense, right? What is a 1's complement? A 1's complement means that we change every 1 to a 0, and we change every 0 to a 1. It's as simple as that. That's what a 1's complement is. So let's take an example of that then. Let's say we want to take the 1's complement of any number. Let's say randomly 1, 0, 1, 1, 0, 1, base 2. Okay, so here I'm going to go, even easier. I'm not even giving a decimal number. I'm giving a binary number. And all I'm going to have to do then is change the 1's to a 0, change the 0's to a 1. I like doing it like this. Oops. I like doing it like this. I like writing down the initial number, and then I like putting little arrows. It just keeps me kind of focused on what I'm doing. I like to remember that this is in the decimal system, so I'll put a subscript there. Subscripts are always helpful. And then I just simply change the 1's to a 2. I'm going to go from this side over, because we like to work on our least significant digits first. Typically, it was a 1, it becomes a 0. It was a 0, it becomes a 1. It was a 1, it becomes a 0. It was a 1, it becomes a 0. It was a 0, it becomes a 1. It was a 1, it becomes a 0. This makes me pretty happy. That was a pretty simple process. So therefore, 0, 1, 0, 0, 1, 0 is the 1's complement of 1, 0, 1, 1, 0, 1, base 2. Great. So that's step 1, isn't it? Because I said to take the 2's complement of a binary number. So this is the 2's complement number, okay? Not the system. This is 2's complement number. How to find it? Step 1, you take the 1's complement. There it is. Done. Step 2, add 1 to the least significant position. Least significant digit. Most significant digit. So let's do that. After the 1's complement has been found, we must add 1 to the least significant digit. It really makes it sound like I'm making stuff up, right? So let's do this all from scratch then as another example. Take the 2's complement. So I'm going to do both steps, okay? I'm going to do step 1. And step 1 is the ones complement, which makes us happy. It's pretty easy, right? So step 1 is the ones complement. So let's write it out. 1, 0, 1, 1, 0, 1. I'm going to convert those two. Ones turned into zeros, zeros turned into ones. I'm repeating what I just did. 0, oops, I'll go from this position. 0, 1, 0, 0, 1, 0. All right, this is the ones complement. And there's no harm in just writing down these redundant words just to remind myself, this is the ones complement. And then we have a step 2. Step 2, in order to get the twos complement, we have to do step 1 and step 2. Step 2, which gets us to the twos complement, is add a digit, right? It means, I'll just say add digit to least significant digit. All right, so our most significant digit is always on this side. Least significant digit is always on this side. So here is our least significant digit. I'm going to add 1 to it. Now, this is kind of a human thing to put this this addition, right? This is step 2. I'm using this human symbol. I'm going to add here because I'm doing twos complement on paper, right? So when I add 1, I say, okay, well, what is now 1 plus 0? What is 1 plus 0? And of course, a 1 plus 0 is going to be a 1. And then the rest is, it's pretty much just zeros, right? So that's going to be a 1, 1, 0, 0, 1, 0. And this, therefore, 0, 1, 0, 0, 1, 1 is the twos complement number. It's the number of our original number, which was 1, 0, 1, 1, 0, 1, base 2. This is not base 2 anymore, okay? Not base 2. This is not a binary number. This is not a binary number. This is yes, twos complement of a binary number. All right. So this is a binary number. This is the ones complement of the binary number. This is the twos complement of a binary number. And that's how we get the twos complement number, which we can later use in a twos complement system.